You're crouched behind a boulder. Savanna, stretching flat in every direction. Nothing moves. Then the lion does. Not fast, not charging. It walks a slow arc around the zebra herd. Deliberate, patient. It stops, waits. The herd shifts. The lion shifts with it. Cuts one animal from the edge without a sound. You're watching all of this. Not because you're brave. Because you're hungry and confused and trying to understand something that keeps killing everyone you know. You don't have claws. You don't have speed. You can't ambush anything. But you have something the lion doesn't know you have. Eyes that can hold a pattern. A brain that can store it. You're watching a predator that's been perfecting its method for 2 million years. And without knowing it, you're about to steal everything it knows. Here's what most people miss about early human survival. It wasn't just about avoiding predators. It was about studying them. Obsessively, continuously. The way a student studies a professor who holds the only answers to a test that decides whether they live. Early humans weren't passive victims hiding in caves and hoping for morning. They were observers, relentless ones, because observation was the only competitive advantage they had. No speed, no strength, no armor, no venom. What they had was attention, and over thousands of generations, that attention became something extraordinary. It became a manual, a living, compounding, inherited manual on how the most lethal animals on Earth operated. And once you understand how a predator works, you don't fear it the same way. You start to see its limits. Let's be clear about what watching a predator actually taught early humans. The first lesson was timing. Apex predators don't hunt randomly. They hunt on schedules, shaped by heat, light, hunger cycles, and territorial boundaries. Saber-tooths ambushed near water sources at dusk. Cave lions avoided direct midday sun because heat impaired their coordination. Short-faced bears moved predictably along river corridors in spring following salmon runs. Early humans didn't learn this from textbooks. They learned it by watching the same animals across dozens of seasons, across generations of passed-down observation. Pattern recognition isn't a modern intellectual skill. It's ancient survival machinery. The humans who could read a predator's rhythm lived. The ones who couldn't were simply removed from the population. That's a brutal teacher, but it's an effective one. The second thing watching predators revealed was weakness. Every predator had one. The saber-tooth was explosive over short distances but exhausted fast. Its ambush strategy required complete stillness before the strike. Move unpredictably. Change direction fast enough. Break the timing window. The cat had no contingency. It wasn't built to adapt mid-hunt. Early humans learned that. Not from a lecture, from watching failed hunts. Watching prey animals survive by breaking the pattern the predator expected. That observation transferred directly. If a gazelle could break a saber-tooth's attack sequence by sudden lateral movement, a human could too. Survival wasn't about being stronger. It was about understanding the exact mechanism by which something kills you and then disrupting it. That's applied intelligence. And it started with watching. Cave painting gets romanticized constantly. People see it as early art, primitive decoration, beautiful but impractical. That's wrong. Chauvet Cave, France. 32,000 years old. The walls are covered with lions, rhinoceroses, mammoths, hyenas, bears. Rendered in precise anatomical detail. Musculature accurate. Posture specific. These weren't decorations. They were records. Visual databases of animal behavior captured by people who spent their lives studying movement and threat. The proportions on those cave walls match zoological measurements taken in the 20th century with scientific instruments. 32,000 years ago, without calibration tools or formal training, early humans drew predators accurately enough to stand up to modern scrutiny. That's not coincidence. That's obsessive, generational study. The cave was the library. The paintings were the data. But here's what makes it even more significant. The information didn't die in the cave. It spread. A hunter who died carrying knowledge of a predator's weak flank approach took that knowledge to the grave. But a hunter who painted it on a wall, who described it to the group around the fire, who embedded it in a story taught to children, made that knowledge permanent. Early humans weren't just observing predators. They were archiving what they learned about them, building an external memory that outlasted any individual brain. No predator on Earth does this. A lion cub learns to hunt by watching its mother. That knowledge chain breaks the moment the mother dies young. Human knowledge chains didn't break, they compounded. Each generation added to what the last one observed. The predators they watched were evolving on geological timescales. Human tactical knowledge about those predators was evolving inside a single lifetime. The ambush was the most studied pattern in early human survival, because it was the one that killed you before you knew you were being hunted. Smilodon fatalis didn't announce itself. It waited in dense cover, sometimes for hours, completely motionless. Biologists estimate it could suppress movement and regulate breathing to near resting levels while in ambush position. Early humans learned to read the silence before the strike. Stillness in grass that should be moving. Bird calls stopping along a specific corridor. Prey animals clustering and facing the same direction without obvious cause. These weren't superstitions. They were environmental signals that said something patient and lethal was nearby. Humans learned to read them by watching what happened in the moments before a predator attacked. The ones who learned the signal lived. The signal got taught, and the fear became a skill. Persistence hunting gets credited as the human breakthrough in predation. And it is remarkable. Humans are the only species on Earth that can run an animal to heat exhaustion across open terrain. No other predator hunts this way. But what's less discussed is where the method came from. Early humans didn't invent persistence hunting from pure logic. They watched predators fail. They watched a lion give up a chase after 300 meters because its body temperature spiked past a recoverable threshold. They watched a hyena abandon a pursuit when the prey hit open flat ground. They observed what made a predator stop, and then they asked, in whatever pre-linguistic cognitive way was available to them, what if we didn't stop? That question, built on thousands of hours of predator observation, is one of the most consequential questions in evolutionary history. It changed the food chain. There's a deeper lesson embedded in all of this. Predators are specialists, built for one environment, one prey type, one method. The saber-tooth's 11-inch canines were extraordinary, also completely useless for anything except a specific killing bite. When prey populations shifted, the saber-tooth couldn't adapt. It had no alternative toolkit. Early humans watching predators weren't just learning tactics. They were learning the cost of specialization, and they were doing the opposite. Broad generalists, eating almost anything, hunting in every climate, building tools for specific tasks and then building different tools for different tasks. The predators they studied were locked into their design. Humans were designing themselves in real time. Watching a specialist operate at peak efficiency teaches you exactly what a specialist can't do. And that gap is where generalists survive. Dmanisi, Georgia. 1.8 million years ago. The archaeological record shows early humans already sharing food with injured group members, already caring for individuals who couldn't contribute to the hunt. That cooperative instinct didn't emerge from nowhere. It emerged from watching how solitary predators died. A saber-tooth with a broken limb starved alone. A cave lion that lost its kill to a larger rival had no fallback. Solitary predators with no cooperative network had no redundancy. Early humans watched that pattern repeatedly across different species. And the lesson absorbed wasn't pity, it was strategy. Cooperative groups survived disruptions that killed solitary predators. The human who helped carry an injured member wasn't being sentimental. They were operating inside a system that their observation of apex predators had proven was more resilient than any individual strength. Fire changed the dynamic permanently. But fire's role in human survival is usually framed around warmth, cooking, protection from predators. What gets missed is what fire let humans do at night. They could watch. Nocturnal predators operate in the dark for a reason. Darkness is a weapon. Cave hyenas hunted in packs of 20 or more after sunset, specifically because humans lost most of their visual acuity after dark. Fire eliminated that advantage. A controlled hearth, extending light 30 feet in any direction, meant humans could observe nocturnal predator behavior for the first time. Watch the pack coordination of hyenas. Study how a lion approached a campsite perimeter, tested it, retreated. Those observations went into the same accumulating database. The predators thought the night was theirs. Humans took that away too. By 100,000 years ago, human social networks were moving information across hundreds of miles. Obsidian tools from volcanic regions turning up at coastal settlements. Materials crossing terrain no single group could cover alone. And with those materials traveled something more valuable. Tactical knowledge. A new method for reading lion territorial boundaries. A plant extract that masked human scent during approach. A spear weighting adjustment that extended range by 10 feet. Knowledge about predators, accumulated over thousands of generations of direct observation, was flowing through networks that span continents. The predators those early humans studied never changed their behavior fast enough to account for it. They were hunting the same creature their ancestors hunted, but that creature had been quietly studying them for 2 million years, archiving every weakness, every pattern, every exploitable gap, and then comparing notes. That's what humans